Hello students, I hope that you are good, well and fine. In today's session, we will be seeing NCERT exercise 7.6, okay, based on the concept of integrals by parts. Okay, so let's see the first question. Integrate x sin x. So very simple. Take I is equal capital I means it represents the integration of x sin x dx. Okay. This means what? Take x as your first function and sin x as your second function. Then what will happen? Quite simple. The first, according to the rule, first function remains as it is. Integration of second function minus integration, now derivative of first function, now integration of second function. This is just nothing but minus x cos x minus, this will be 1, this will be minus cos x, this becomes plus cos x, this will becomes now integration sin x. So minus x cos x plus sin x plus c will be your answer. Okay, let us move to the next question. X sin 3x, same. Capital I is equals to integration of x sin 3x dx. Taking x as first function and sin 3x as second function, you can integrate it by using by parts. Okay, so x integration sin 3x dx minus derivative of first integration sin 3x dx. This means x minus cos 3x divided by 3 minus integration of 1 multiply with minus cos 3x divided by 3 dx. Now minus x cos 3x divided by 3 plus 1 by 3 integration cos 3x dx. This means minus x cos 3x divided by 3 plus 1 by 9 sin 3x plus 3 plus c. Okay, the third problem. Capital I will be integration of x square ex dx. X square will be our first function, ex will be our second function. So this means I is equals to x square integration of ex dx minus derivative of first integration of second. This gives you x square ex minus 2x multiply with ex. This means x square ex minus 2 times of x ex. Now this will be what? Apply isolate here or by parts here. What you can get is x square multiply with ex minus 2 times of first function as it is, integration of this minus integration derivative of first function integration of second. You can get is x multiply with ex multiply with 1 multiply ex. So this will be just integration of ex. You can get x ex minus ex. Now multiply with minus 2 inside. What you can get is x square ex minus 2x ex plus 2ex plus some constant. So the final answer will be, so take ex common, you can get ex multiply with x square minus 2x plus 2, okay, plus some constant. Okay, simple. Now fourth problem, x log x integration will be, take log x as your first function and x as your second function. So this means what? Log x integration of a second function minus differentiation of first integration of second. This means log x square by 2 minus 1 by x multiply with x square by 2. 1x will be cancelled. You left with x square log x divided by 2 minus integration of x by 2, and integration of x by 2 is just nothing, x square by 4. This means x square multiply log x divided by 2 minus x square divided by 4 plus c will be your final answer. Okay. Now fifth problem says x log 2x. Okay, so what will be your integration? Quite simple, use by parts. So taking what? Okay, so take log 2x as your first function and x as your second function. So this means log first function will be as it is, integration of second minus integration derivative of first and integration of second. So this gives you log 2x multiply with x square by 2 minus 2, the integration of 2 times log x will be, sorry, derivative of 2 times log x will be 2 divided by x. Okay, 2 divided by x. Okay, clear? Okay, sorry, it must be 2 divided by 2x. Okay, so here must be 2x. Okay, so log of 2x, we are talking about log of 2x. Simple. Okay, clear. Okay, so derivative will be, as you can see, a log 2 times log of x. Simple. Okay, now integration of this will be what? X square by 2. As you can see, after simplification, what you get is x square log 2x by 2 minus integration of x by 2 dx. Okay, now x square log 2x divided by 2 minus x square by 4 plus c will be your final answer. Okay, I hope it is clear to you. Simple. Okay, let us move next. Now, sixth problem. Take log x as your first function and x square will be your second function. Now log x, first function remains as it is. Integration of second, which is x cube by 3, minus differentiation of first, which is 1 by x. Integration of second, which is x cube by 3. 1x will be cancelled. You left with x cube log x by 3 minus integration of x square by 3. Now integration of this will be x cube by 9. So x cube log x by 3 minus x cube by 9 plus some constant will be our final answer. In seventh problem, sine inverse x will be your first function and the remaining x will be your second function. So now, first function multiply with integration of second. Integration will be x square by 2. Now minus differentiation of first is just nothing, 1 by root 1 minus x square, multiply with integration of second, which is x square by 2, as you can see. And now what is happening is quite simple, that as x square sine inverse x by 2 plus half integral of minus x square, okay, root 1 minus x square. Okay, now what I am taking, what I am doing is adding 1 and subtracting 1 in numerator. So what can you get is 1 minus x square divided by 1 minus x root of 1 minus x square minus 1 by root 1 minus x square. Now separate them. What you get is x square sine inverse x by 2 plus half of integral of root of 1 minus x square minus 1 by root 1 minus x square dx. So this means x square sine inverse x by 2 plus half of integral root of 1 minus x square dx minus integral of 1 by root of 1 minus x square dx. So x square sine inverse x divided by 2 plus half of x by 2 root of 1 minus x square plus 1 by 2 sine inverse x minus sine inverse x plus c. This means your final answer will be 1 by 4 2 times of x square minus 1 sine inverse x plus x by 4 root 1 minus x square plus c. Okay. Now eighth problem, tan inverse will be your first function and x will be your second function. So this means tan inverse x integration of this will be x square by 2 minus differentiation of this will be 1 by 1 plus x square, multiply with integration of this will be x square by 2. This means x square tan inverse x by 2 minus half integration of x square 1 plus x square dx. This means this term will remains as it is. So minus half, what we are doing, adding and subtracting 1, you are getting x square plus 1 by 1 plus x square minus 1 by 1 plus x square. This means this will be cancelled. You get 1 minus this will be just 1 by 1 plus x square dx. Now you can see this integration can be reduced at minus half of multiply with x minus tan inverse x. So this means minus x by 2 plus tan inverse x by 2 plus some constant will be your final answer. Okay, clear? Okay, now the ninth problem is x cos inverse x. Okay, so this means your inverse function will be your first function and x will be your second function. So according to the by parts rule, so first function remains as it is. So cos inverse x, integration of second will be x square by 2 minus differentiation of first is just nothing, minus 1 by root 1 minus x square, multiply with integration of x, which is x square by 2. Now this minus gives you what? So x square cos inverse x by 2 minus half of, so what you are doing is adding and subtracting 1, you get 1 minus x square minus 1 root of 1 minus x square. As you can see, after you separate them, you can get is root of 1 minus x square plus minus 1 by root 1 minus x square dx. You know this integration is what integration? So I'm taking this integration as I1, and this integration is just nothing but cos inverse x. Okay, this integration is just nothing but cos inverse x. Now for to evaluate I1 integration, what I'm going to do is quite simple. Okay, so I'll be doing what? The applying applying by parts rule over here. So one will be what my second function, and this will be what my first function. So first function as it is integration of second, which is just x, minus derivative of first will be 1 by minus 2x by 2 root 1 minus x square. Now integration of 1 will be just x. Okay, now what you will do is, as you can see, you can have I1 is equals to x root 1 minus x square minus integral of minus x square root 1 minus x square. So add and subtract 1 from the numerator, you can get this form, and after separating this form you can make this form. So this will be root of 1 minus x square plus integration of minus dx by root of 1 minus x square. Okay, as you can see, this is just nothing, x root 1 minus x square remains as it is. This will be what? Minus I1. This is same as I1. Okay, as you can see, I1 is what? Your integration of root 1 minus x square. So same thing. Okay, plus this will be plus cos inverse x. Okay, so this will becomes 2 times of I1 is equals to x root 1 minus x square minus cos inverse x. So this means I1 is equals to x by 2 root 1 minus x square minus half of cos inverse x. So substitute your I1 back, you will get this as your final answer. Okay, now 10th problem. The 10th problem says sine inverse x whole square. Okay, so very simple. So take this as your first function, 1 as your second function. Now first function as it is, integration of this will be x, derivative of this will be what? As you can see, 2 times of sine inverse x divided by 1 minus x square. Now integration of this will be just x. Now just rearrange the term, you can get is sine inverse x multiplied with minus 2x divided by 1 minus x square. Now as you can see, again apply the by parts rule. So first function as it is, integration of this minus derivative of first function, which is 1 by root 1 minus x square. Now integration of this is just nothing but 2 times of 1 minus x square thing. Okay, so from here you can see this term and this term will be cancelled. The integration of 2 will be 2x, so this will be minus 2x, and the integration of this is just nothing but 2 root 1 minus x square. Okay, I hope it is clear. So after simplifying, you will get this as your final answer. Okay, after simplifying, you will get this as your final answer. Simple. Okay, now let us move to the next problem. Problem 11. Problem 11 is integration of this. So take cos inverse as your first function and this as your second function. So what you will get is first function. Okay, so simple. So you will get what? So what I'm using is multiplying with minus 2 in numerator and denominator, you get minus 2x divided by 1 minus x square, and in also we are going to multiply with minus 2 with the denominator, you will get minus half common. Okay, so now you are left with this term. Now take cos inverse x as your first function and the remaining thing as your second function. This means what? That minus 1 by 2 cos inverse x integral of this minus differentiation of first function integration of second, you can get is cos inverse x differentiation, sorry, integration of this is just nothing, 2 times of root 1 minus x square minus integration of derivative of this will be minus 1 by root 1 minus x square. Integration of this is 2 times of root 1 minus x square. So this term and this term will be cancelled. You only left with this as your term. So now after integrating this will be just 2x. So your final answer will be minus root of 1 minus x square multiplied with cos inverse x plus some constant. Okay. Now 12th problem. Let I is equals to integral x sec square x dx, taking x as your first function and sec square x your second function. Integrate by using by parts. We obtain a first function which is your x. Okay, x integration of second will be tan x, differentiation of first will be 1, different integration of second will be tan x. Now you know integration of tan x, which is just minus log modulus cos x, or in terms of sec x it is just log sec x. Okay, so whatever the form you chooses you can choose. So this will be your final answer in terms of cos x. Okay, clear? Okay, the 13th problem says integrate this. So I will be my second function, sorry, 1 will be my second function, tan inverse will be my first function. So first function as it is, integration of this will be just x, differentiation of this will be 1 by x square. Now integration of this will be just x. Now what you have to do, just very simple. So multiply and divide by 2 in numerator and denominator. So you can get what x tan inverse x minus half integration of 2x divided by 1 plus x square. So this is just nothing but minus half log 1 plus x square plus some constant. Okay, clear? Okay, so this means what you left with just nothing but this will be your final answer, x tan inverse x minus half log 1 plus x square. Okay, now 14th problem, x log x whole square. So take log x whole square as your first function and what, and x as your second function. So this means if taking x as your second function, so first function as it is, integration of this will be x square by 2, differentiation of this will be 2 log x by x as you can see, and integration of this will be x square by 2, 1 x will be cancelled, 2 will be cancelled, you only left with x log x. So I will be this thing. Now again we are going to apply by parts here. So you get first function here, second integration of second will be x square by 2. Okay, now derivative of first function, integration of second, you can get this. So 1 x will be cancelled, taken half common, you left with what? So because of this minus sign you left with, so this must be not here. Okay, this must be just a multiple sign. Okay, clear? So it will be minus x square by 2 log x plus half of integration of x. This means x square by 2 log x whole square minus x square by 2 log x plus x square by 4 plus some constant. Okay, clear? I hope it is clear to you. Okay, so now what? So this must not be here. Okay, not here. Clear? Okay, I hope it is clear to you. Okay, let us move next. Now 15th problem. 15th problem says integrate this. So log x will be what? Your first function, obvious thing. So but we have to evaluate it separately. How? So integration of x square log x dx plus log x integration of log x dx. Okay, I1 plus I2. I1 is integration of x square log x dx and I2 is just this. So in I1 take log x as your first function and this as your second function. Now first function integration of second. Okay, so remove this minus, multiple sign must be there. Okay, so log x multiply integration of this will be x cube by 3 minus differentiation of this will be 1 by x and integration of is x cube by 3. So 1x will be cancelled, you left with x cube by 3 log x minus 1 by 3 integration of x square dx. So this means x cube by 3 log x minus x cube by 9 plus some constant. Okay, this is for your I1. Now for I2 integration of log x, as we already saw such type of integration, we took log x as your first function and 1 as your second function. So this means I2 will be log x multiply x minus integration of 1 by x multiply x dx. So this will be x log x minus x plus some constant. Now substitute them, you will get x cube by 3 log x minus x cube by 9. plus some constant plus x log x minus x plus some another constant. Now taking this constant and this constant, add them, you will get another constant. I'm naming it as a c. So your final answer will be this after rearranging some terms. Okay. Now 16th problem. 16th problem says ex sin x plus cos x. Now as you can see, this is of form ex fx plus f prime x. Okay, so sin x derivative is cos x. So your final answer will be ex sin x plus some constant. Okay, as you can see, ex sin x plus some constant. Okay, now the same thing. Okay, so what you are doing is now separate. Okay, so you have to form your form like integration of ex multiply with fx plus some f prime x. Okay, so add and subtract my 1 from numerator. You will get ex multiply with 1 plus x minus 1 divided by 1 plus x whole square. So this can be rewritten as integration of ex multiply with 1 by 1 plus x minus 1 by 1 plus x whole square. Now as you can see, the derivative of this will be this. So this means your final answer will be ex 1 multiply with 1 divided by 1 plus x plus some constant, as you can see, because you are having this as your form. Okay. So here must be what? The brackets. Okay, brackets must be there. Simple. Okay, I hope it is clear to you. Okay, so use brackets. Okay, now the next. So again we have to make our form ex multiply with fx plus some f prime x. Okay, so how can you make? Quite simple. 1 plus sin x, I can break it into, first of all, 1 can be rewritten as sin square x plus cos square x by 2. Okay, now this sin x can be rewritten as 2 sin x by 2 cos x by 2. Okay, now this 1 plus cos x can be rewritten as 2 cos square x by 2. Okay, as you can see in numerator, this is the whole square thing, which is sin x by 2 plus cos x by 2 whole square. In denominator, this is just nothing but the cos x by 2 whole square. So I can rewrite, after taking half common, you can get half of ex multiply with sin x plus by 2 plus cos x by 2 divided by cos x by 2. Separate them, you can get tan x by 2 plus 1 whole square. So this means half of ex. So it must be ex. Okay, ex. Okay, so half of ex 1 plus tan x by 2 whole square. So half of ex 1 plus tan square x by 2 plus 2 tan x by 2. Okay, as you can see, what is happening after expanding this square, you can get x sec square x by 2 plus 2 tan x by 2. Now different, if you know that 2 tan x by 2 differentiation is what? 2 times sec square x by 2 multiply with half. So this means sec square x by 2. So this means this is of the form fx plus f prime x, where fx is your 2 tan x by 2. This means your final answer will be half of ex 2 tan x by 2. Half of, okay, half of ex 2 tan x by 2. The 2 and from the numerator and denominator will be cancelled. You only left with ex tan x by 2 plus some constant. Okay, clear? Let us move to the problem number 19. So problem 19 say integrate this. So integration of this will, as you know, take fx is equals to 1 by x. You know the derivative will be minus 1 by x square. So this form will gives you your answer as ex fx plus c. So this means I will be ex by x plus some constant. Okay, now 20th problem. 20th problem says integrate this ex multiply with x minus 3 divided by x minus 1 whole cube dx. This means ex is equals to, now what we are doing, we are separating or we are rewriting this 3 in this form as x minus 1 minus 2. Okay, now this can be rewritten as what? As you can see, this can be rewritten as ex multiply with, okay, 1 by x minus 1 whole square minus, okay, minus 2 by x minus 1 whole cube. This means the derivative of this, as you can see, 1 by x minus 1. Okay, so use what? So here it must be here must be what, brackets here. Okay, brackets. Clear? Now a derivative of 1 by x minus 1 whole square will be, as you can see, fx is, if fx is this, the derivative will be minus 2 divided by x minus 1 whole cube, the same thing which is written over here. So this means this follows this form. Okay, and the answer for such type of form will be ex multiplied with fx plus some constant. Fx is this, so this means ex divided by x minus 1 whole square plus some constant will be your final answer. Okay, now 21 problem. Now problem number 21, the same thing. So here we are going to use y parts. Okay, this is not some type of we cannot make this okay quickly. Okay, we cannot able to rectify it in this form. What form? That ex multiply with fx plus f prime x form. Okay, so we are using the fast way, which is by parts. So what is your first function, which is a sin x. Okay, so first function as it is, integration of second minus integration of second is what, e2x will be e2x divided by 2. Now derivative of first will be just cos x and integration of this will be e2x by 2. Now as you can see, I is equals to e power 2x sin x by 2 minus half of integration of e2x cos x d. Now use by parts again in this form or for this. Okay, so I'm just telling about this integration. Okay, so the first function will be cos. So first function as it is, integration of this will be e power 2x by 2. Okay, minus differentiation of this will be minus sin x. Now integration of this will be e2x by 2. Now as you can see what is happening, so this will be your I. Now observe this, this can be rewritten as plus of integration sin x half of plus of half of integration of e power 2x sin x dx. Now see, integration of e power 2x sin x dx is what, your I. Okay, so this is just nothing but half I. Okay, this is just nothing but half I. So multiply with minus half here, you will get minus of e 2x cos x by 4 minus 1 by 4 I. Take this I thing to the left hand side, you will get this. This will become 5 by 4 I. Okay, which is equals to this term, and I becomes now e power 2x divided by 5 multiply with 2 sin x minus cos x plus some constant. Okay, so in this way you can complete your answer for this problem number 21. Now 22, sin inverse x 2x by 1 plus x square. Now what, substitute, we use substitution here. So take x is equals to tan theta. You know 2 tan theta 1 plus tan square theta is what, just nothing, to sin 2 theta. Okay, so sin inverse, after substitution you will get this sin inverse 2 tan theta 1 plus tan square theta. This means sin inverse tan 2 theta. Why? Because sin 2 theta is 2 tan theta divided by 1 plus tan square theta. So this will gives you just 2 theta. Now integration of this will be same as doing the integration of what? So as we just substituted, this means dx is equals to sec square theta d theta. Okay, dx will be sec square theta d theta. So dx can be replaced by sec square theta d theta, and this term will be replaced by just 2 theta, as you can see 2 theta. Now we are able to use the by part thing. So by part thing will be, first function will be theta. Okay, so the first function as it is, integration of this will be just tan theta, differentiation of this will be 1, and integration of this will be just tan theta, and you know that tan theta integration directly. So your final answer, not the final, but your answer will be 2 times of tan theta plus log modulus of cos theta plus some constant term. Now 2 times of, in terms of x we want our answer, so replace it. So theta was x is equals to tan theta, and theta will be what, tan inverse x. So this means x theta will be tan inverse x. Tan theta is just nothing but x. So x tan inverse x plus 1 by root 1 plus x square plus some constant. So this will be your final answer. If you try to see, okay, by using the by using logarithmic property, you will get this is of what form, log of a by b. So log of a by b can be reduced to log a minus log b, and log 1 always gives you 0. So that's why we wrote 2 times log 1 plus x square power minus half. So this can be rewritten as this. Using log property, you will get your final answer in this form: 2x tan inverse x minus log 1 plus x square plus some constant. Okay, I hope it is clear to you. Now problem number 23. So integration of this we have to do. So we will be using what? First of all, we will be using the substitution. Take x cube is equals to t. So this means dt by dx will be what? 3x square. Okay, so this means x square dx can be replaced by dt by 3. So we replaced it. So dt by 3. Okay, and this will be what? E power t. Now integrate it. Integration of et is just nothing but et. So et by 3. Now t is what? X cube. So your final answer will be e power x cube by 3 plus some constant. Okay, I hope it is clear to you. Okay, let us move to the last problem of this exercise 7.6. Okay, so after doing the problem number 24, we will be stopping there. Okay, so let's see. So integration of this we have to find. So this is just nothing but we have to somehow make ex multiply with fx plus f prime x form. Okay, so one thing is very clear. Let me just show you that after multiplying with sec x, inside you will get ex multiply with sec x plus sec x tan x. Now take fx is equals to sec x, and this gives you f prime x will be what? Sec x tan x. So this means this is of the form what? This is of the form ex fx plus ex f prime x. So this means this answer will be ex fx plus some constant. Okay, so this gives you integration I is equals to ex sec x plus some constant. So option B. So option B will be your correct option. Okay, option B will be your correct option. I hope it is clear to you. So this is it for 7.6 exercise of this chapter, integration, based on the concept of integrals using by parts, and also this special kind of integration which is ex multiply with fx plus f prime x. Okay, so this is it. We will be back with some more problems of and also some more concept how we evaluate our integrals. Okay, next time. Okay, so thank you all.